examples together. So factoring is a handy way if you have a big hairy thing. So like a spider-like math problem, sure, like a big hairy thing with lots of legs that go everywhere, factoring it. Like for example, like we had our bell work today was twice the sum of A plus B, okay? So how many A's am I gonna have?
1.
Okay, let's draw this out. I have an A. This is A. And I have a B. Do we know how big these are?
No.
How many of each one do I have?
1. 2. Wait. Oh.
Okay, so this is this A plus B?
Yeah.
So if I have, so now I have twice the sum of A and B, right? This is A plus B and this is A plus B. Well, how many A's do I have?
2.
So could I say that I have 2 A's?
Yeah. 2.
And how many B's do I have?
2B.
Plus 2B. So it's a different way of saying the same thing. Do you guys see that? So this is the sum of A plus B twice, but I could write it as 2 A's and 2 B's. So let's do example 1. We have 2 5s and 2 3s. So we're going to use real numbers on this one. So we have a 5 and we have a 5 and we have a 3 and we have a 3. Okay? So how many 5s do I have?
2.
2 5s. So I have 2 times 5. How many 3s do I have?
2.
2 times 3. Okay? So how would I represent this in words? We practiced with words yesterday. How would I represent this in words? How could I? There are a couple different ways.
2 times. No.
Zach, go with that.
2 times 5 plus 2 times 3.
Is this correct?
Yeah.
2 times 5 plus 2 times 3. Is there another way to put it? What about how this one was put?
2 5 plus 2 3.
2 times the sum of 5 and 3. Is that also correct?
Yeah.
Is either one more correct?
No. Oh.
No, this one uses fewer words. So if we're feeling lazy. But they're both correct. McKinley.
5 to the, wait, never.
No, it's not 5 to the 3rd power. She was wanting to go down that road. But you know what I love? Your brain started to go down that road and then you were like, oh, wait, no, that's wrong. And it's fabulous that you caught yourself.
5 squared.
Is it 5 squared? This
Yeah.
isn't 5 squared.
No, wait.
5 squared is 5 times 5. So I would need to have 5 5s for that to be 5 squared. So it's 5 times 2 and it's 3 times 2 or 2 times 5 or 2 times 3. It doesn't matter, right? Because we learned the commutative property of multiplication. They're the same. Okay? So that's pretty much it. Okay? So what if we have, well, this probably best represents that. But if I put a 5 times 3, this is 5, this is 3, this is 5, this is 3, right? Then this one's probably a little bit more accurate. But are they really any different?
No.
They're the same thing. Right? We just switched the order, but we learned with the commutative property of addition, can we switch around this order all we want?
Yeah.
Wait, it doesn't even matter. We can switch this order around all we want.
5 plus 3 plus
5 plus 3 equals 3 plus 5 equals 5 plus 3 equals 3 plus... It's really only 2 orders. But we could have 5 plus 5 plus 3 plus 3, or 5 plus 3 plus 5 plus 3, or 3 plus 3 plus 5 plus... Doesn't matter. Okay.
Or 3 plus 5 plus 3 plus
So,
5.
I'm going to let you guys finish that example on your own. But they're equivalent, right? Okay. So now let's let's look at it with variables. We kind of did that over here. We're going to do it a little bit more. Okay. What if I have this is A, and this is A, and this is B, and this is B. How would I represent that with words? How many A's do I have?
2.
2. This is 2 A's, and how many B's do I have?
2.
So is this 2A plus 2B? Or I could say the sum of 2A and 2B, right? I could model that with the sum of 2A and 2B. Is there another way I could write this though? What if we flip it over and we do like what we did here? Okay, what if we flip it over and I have an A and a B and an A and a B? Does changing the order change anything?
No.
So what do I have here though? I have
Changing the order does change
2
one thing.
A plus B's, right? Is it different? Are 2A plus B's any different than 2A or 2B?
No.
Okay, so I'm going to teach you about something that's called the distributive property.
Oh, I was hoping you said destructive.
The destructive property of mathematics. It's handy if you're building bombs.
Yeah.
Or let's say you have to demolish a building, you have to know what force is necessary on your wrecking ball, right? So math can be destructive, but not today. It's going to be distributive.
Oh.
So let's say I have twice A plus B, like in our bell work there.
But it's 7.
We're not going to worry about the 7 right now. We're not going to worry about the 7. I mean, we could say it is 7. That 7's just going to be sitting there, so we're
It
just
could
not
also
even
be
worry about it.
700.
So A plus B would be 3.5 times 2 is 7.
You're right. We don't know what A is and we don't know what B is, but we know that A plus B is 3.5. Go, Zach, go.
Is 2.
Okay, let me show you how to do this though. Because we know that 2 times A plus B is 2A plus 2B, because we saw that we can rearrange this. So let me show you how to do this mathematically. This is 2 times everything in here. So what I do is I tell myself I need to multiply this 2 times the A. And I actually draw those little arrows when I'm doing these so that I don't forget anybody. Well, what's 2 times A?
A.
Not A. A is A times A.
It's just 2A.
It's just 2A. 2 times A is just 2A. Do I know what A is?
No.
What sign is in between them?
Plus.
So that sign comes down unless there's a negative there and then signs get switched up. But,
And then what?
and what's 2 times B?
A B. 2B.
So I'm going to take this over here so I remember
2B.
2B. Or not 2B. That's the question. Alright, are these equivalent expressions?
Yeah.
Because if I draw these out, are they the same thing?
Yeah.
These are in pink and these are in green, so these are a little bit better. But, so I like green better than pink. But they're equivalent expressions. So I have that. Now, the question is, can I go backwards? Let's look at example 3. What if I have 3F plus 3G? Can I go backwards? So, do you remember when we learned about greatest common factor?
I think so.
Zach thinks so. Does anybody remember?
Which
Yes,
one was that?
we
The one
did.
that goes down or the one that
We
goes
did.
sideways?
Okay, what is a factor, first of all? Let me take off my hoodie.
Jinx.
McKinley, what's a factor? I said her name, so she's not jinxed anymore.
Yeah, so did Murray.
Who remembers what a factor is? What was that?
A factor is kind of like something that goes.
Something that goes into something. Like if I have 24. 24 is one of my favorite numbers because it has a gazillion factors. What can 24 be evenly divided by? What are the factors of 24?
2, 4, 6.
Let's start at the bottom. Is 1 a factor of 24?
Yes.
Yeah.
Can't forget 1. 1's super important. We love the number 1. Is 2 a factor of 24?
Yeah.
Yeah.
Is 3 a factor
Yeah.
of 24? Is 4?
Yeah.
Is 5?
Yeah.
No.
No. Is 6?
Yeah.
And now we're going, because 4 times 6 is 24. Now I don't have to test every number. I just look, what do I multiply 3 by to equal 24?
8.
What do I multiply 2 by to equal 24?
12.
What do I multiply 1 by?
24.
24.
So those are all the factors of 24. Give me another number.
63.
What?
19.
19's prime. We're not using a prime number.
69.
What? Let's do 30. Should we do 30? We'll do 30. Okay.
I feel like this is something he wanted us to do. Number 30.
Yeah, you guys didn't give me good numbers, so I had to come up with one of my own. You guys kept giving me prime numbers. Actually, 63 would have worked, but we're gonna do 30. Okay. Let's list the factors of 30. Is 1 a factor of 30?
Yeah.
Is 2
Yeah.
Yeah.
3?
Yeah.
4?
No.
4?
No.
No.
No. Because 4 times 8 is 32, and 4 times 7 is 28. So 4 times 7.5 is 30, but we don't count those. We're just looking for the whole number factors. So skip 4. 5!
Yeah. Nah. Yeah.
Yeah, because 5 times
Yeah.
5 times 6 is 30. So now do I need to test every one?
No.
No, now I just look at this. What 3 times what is 30?
10.
10. 2 times what is 30?
15.
What?
15.
15. And then 1 times 30 is 30.
Yeah. I said 15, not 50.
So what's the greatest common factor of these two? Which factor that's on both of these lists is the biggest?
6.
6. 6 is the greatest common factor of these two. Okay, you guys remembering this? It's been a minute since we've done greatest common factoring.
It's actually been a little long.
It's been a minute or two.
Yeah.
Okay. It's been 2 or 3 minutes. All right, so let's come back to here, guys. What are the factors of 3 and F or 3F? I just totally answered my
3
question.
times F.
3F is 3 times F, so it has 2 factors. Well, it has 3.
Just one.
It has 4.
What?
Well, no, only has 3. 1, 3, and F. We're not going to ever count 1. We don't care about 1. Ignore 1. We love 1. We're going to ignore 1. 1 doesn't count.
We don't care about 1 because 2 stole its W.
2 did steal 1's W. All right. What are the factors of 3G?
The 3 and G and
3 and G. So what is the greatest common factor of these two?
3.
3. They have a greatest common
Yes.
factor. Even though we have letters going on in there and all this stuff, they have a greatest common factor.
Wait, wouldn't it be G because it's above 3 in the alphabet?
Is
but
there a
it's
G in this term? There isn't a G in this term. I don't know what G is, but I know it's not sitting there. Now, if G is 2 and F is 4, then G would be a factor of F. But I don't know what G is, and I don't know what F is. So I can't say that G is a factor of F. Maybe it is. Maybe it's not. I don't know. But I know for sure that 3 is a factor. So what I can do is I can say, I'm going to pull this 3 out of both of them and say, because I have this plus sign, 3 times F plus G. Do you guys see how we went backwards?
3 and G.
Here we said 2 times the sum of A plus B, and then we got to 2A plus 2B. And here I had 3F plus 3G, and I pulled that 3 out and stuck it in front. Is that a legal thing to do?
Yeah.
Yeah, it totally is. Why would I want to do that?
I said that.
Because we're lazy.
Not because we're lazy, because sometimes, like what if I have 3F plus 3G divided by 18? What I can do is I can pull that 3 out and I can say 3 times F plus G divided by 18. And then I can reduce 3 18ths.
6.
and then it's just
6y.
f plus g over 6. We're not doing that yet, but that's why we would want to do this, okay? Just kind of looking towards the future.
How do we figure out f plus g? How do we figure out what those are eventually?
That will be at the end of 8th grade.
Oh gosh.
Okay. Like my 8th graders, we haven't gotten there yet. We'll probably get there in May.
Oh gosh.
I hope we get there before the ice axe, but we probably won't. So you'll solve for F and G in the 8th grade. So that'll happen. It'll happen, but not today,
Will it
and that's
be
okay.
F and G?
If you want it to be F, you usually use X and Y at that point, but you could substitute in F and G, as long as we're not graphing. If we're graphing, you're stuck with X and Y, but if we're not graphing, you can use whatever variables you want, just not I and O.
Well,
And maybe not E.
Because wait, fine.
I owe
But
you
probably
usually.
why?
Not the old McDonald letters.
Oh, my
E-I, and O.
Oh, McDonald.
Don't use the old McDonald
Old
letters in
McDonald
algebra.
divided by 0.
Old
E-I-E-I-O.
McDonald did some math, but not with E-I-E-I-O. I am so sorry for that. That was so horrible.
Old McDonald divided by 0 with E using E-I-E-I and O.
Okay. So we're gonna do number 2 together, guys. Number 2. So that was example 1, and I kind of got you. Well, let's finish example 1.
What?
Oh,
Wait,
Let's
that
finish
was-
example 1.
But we were just, but
Oh, example 3.
Example 3.
It's example 3. Okay,
Well-
so what is the question asking us to do?
I don't know, something amazing, I guess.
Thanks for making me smile, Zach.
Like,
seriously.
It's asking us to do math.
Math? It's asking us to add 3F and 3G. Can we do that? No. But what's the greatest common factor there?
3.
3. And then we use the greatest common factor to rewrite the expression.
Yeah.
Okay, now this next one is going to be a little bit more challenging. Can we do more challenging? Can we do more challenging?
Yeah.
Can we do it?
No.
No.
Yeah.
Not sorry.
Did you guys ever watch Bob the Builder?
No.
No.
I watched.
Oh my gosh,
Blue's
you guys
Clues
never
and
watched Bob
Oswald.
the Okay,
I watched
so Bob goes, Bob has his team of machines and they're talking
His what machines?
they're talking construction vehicles.
I watched Blue's Clues and Oswald.
My kids watched a lot of Bob the Builder, and they have this tough job, and there's this crane called Lofty, or maybe he's a lift. No, he's a crane. There's this crane, and there's this Dizzy, and she's a cement truck, and there's Scoop and Muck. Scoop is a scooper, and Muck has she's a I don't know, shover thingy, bulldozer. Thank you. So anyway, and Bob goes, "Can we build it?"
No.
And then all of his team goes, "Yes, we can." And then Lofty goes, "I think so," because Lofty's not so sure. So can we do it?
I think so.
Yes, we can. And then Zach says,
I think so.
"You guys didn't want to Bob the Builder."
Next time she yells, "Can we do it?" we should all say, I think so. Perfect unison.
Yeah.
I've had 8th graders go, "No, we can't," and I'm like,
I do that all the time, especially when we make choice.
all right. So we have 6x plus 9y. Okay.
Wait.
What is this expression asking us to do?
Um.
I'm on number 2 on the next page.
Okay.
Add 6x and 9y.
Add 6x and 9y. Austin's here!
Austin!
Austin, you missed out on so much stuff.
Sit right there.
All right, so what's
Knew
the greatest common factor here? Last time it was super easy because it was 3. What?
It's 3.
Is it 3? What are the factors of 6?
It's
1,
1, 2,
2,
3,
and 3,
and 6.
and 6. What are the factors of 9?
1,
1,
1,
2, 3.
and 9. What's the greatest common factor?
3.
3. It was. I made us go through some difficultness to get there. But it is 3. So can I pull a 3 out of this? out.
You cut it in half.
I cut it in half. Actually, yeah, and I pull a 3 out. There's 2 3s. 6 is really, guys, just, could I write this as 2 times 3 times x? And could I write this as 3 times 3 times y? Could I? Is that legal?
Mhm.
Sure. So let's pull this 3 out. I'm going to have this 3. What do I have left? A 2x. Can I pull both of these out and be left with y?
Yeah.
Well, because what's 3 times 3? 9. 9. Are there any 9s over here?
No.
No. So if I'm only pulling 1 3 out, I can only pull 1 3 out. So then I'm left with this one goes away, this one goes away, and I'm left with 3y. So this is 3 times the sum of 2x and 3y. What? In the what? All right. Now we're going to go the other direction. Okay. Flip the page to the next example 1. Okay, you guys there? Are you on the next example 1? Turn the page.
Two.
Do you guys see it? Do you guys see it? Are you there? Turn the page.
It's like a maze. Oh, there we are.
Okay, it says write an expression that is equivalent to 2 times a plus b. And we've kind of done this to death today. First of all, you know what? Let's have one of you do it because we have done it to death. Let's pull a stick, but not Austin because
But
he just got it.
I'm dead though. If we did it to death, then I'm dead and I can't do
This
it.
is what's dead. We're gonna revive it and make it alive again.
Okay.
We're gonna pump some 6th grade Forest. Can you show me what this would look like as a model? A plus B as a model.
No.
Just draw me A plus B. However you draw A plus B.
A plus B.
Just A plus B.
So just A plus B.
Like as a model. So draw the little rectangles and stuff.
Ooh, look at a rectangle here. Look at a rectangle.
Okay, what's that rectangle gonna be? A or B?
That's gonna be split into 2. We have A and B.
Woo! He's a wild man. Can you draw 2 of those?
I
To
can't.
show me 2A plus B? Forrest, go grab a tree, because that was beautiful. Did you do that? Did you do it well? Does that show me 2 of A plus B?
Yeah.
Totally it does. And he did a lovely job of it. Now what does it say next to us? So, how many A's do I have? 2. So I have 2 A's plus, how many B's do I have? 2 B's. Or I could have done it this way and said, okay, I have 2 times A is 2A. And I have plus, because the plus sign's in the middle, 2 times B is 2B. Mine is lowercase and his is capital. Does that matter? No. Are they the same?
Yeah.
This is how you do it with the model. This is how you do it not with the model, okay? So you're going to have to draw some models, but do you always have to draw the models? No.
No.
So what happens if we double A plus B?
It's
What?
2 times A.
Okay, turn over the page and we're going to do example 2. So we're going to double 3x plus 4y. So when I double that, what am I multiplying it by?
2.
2. Okay. How can we rewrite this? What do I multiply first? I multiply the 2 and the 3x.
No, you would add the 3x plus 4y.
Can we add 3x plus 4y?
No.
Are they like terms? They're not the same, so we can't add them. It's like adding Skittles and M&Ms. Can I add Skittles and M&Ms?
No.
No, I can't add Skittles and M&Ms. I can't combine these.
Do we find the greatest common factor of them?
No, we're going backwards. We're doing it the other way. Is there a greatest common factor here to factor out? No, but there will be in a minute. We're going backwards from factoring though. So we factoring the first half of the assignment, and we're multiplying, we're unfactoring the second half of the assignment. So what's 2 times 3x? If I have 3x and I have it twice, I have 6x, right? I multiply the numbers and the x comes along for the ride. But if I have, like I'm gonna change this to M and S. If I pick up 3 M&Ms twice, how many M&Ms do I have? 6. I picked up 3 M&Ms twice, so I have 6 M&Ms. If I have 4 Skittles and I pick it up twice, how many Skittles do I have?
8.
8 Skittles. So I could go backwards now and factor out a 2, but that's not what we're doing on this. So first half of the assignment, you're pulling it out. Second half of the assignment, you're putting it back in, okay? There's value in doing this too, okay? So if we do, let's do example 4, okay? So we're gonna do 3 times 7D plus 4E.
4E is 70. 4E 70.
What?
Wait, you used E.
Like
You
70
used
and 40.
E.
They used E. They didn't get my memo that to not use E, but they
70
used
and
E.
40.
We're not gonna worry about it. What?
70 and 40.
Okay, so what am I gonna do first? What do I multiply here? What do I multiply first? I'll draw my little rainbows, right? I'm gonna multiply these two. What's 3 times 7D?
21D.
21D. Plus, now I need to multiply the 3 by this one. Everybody gets a piece of that 3, okay? Everybody gets this 3. The parentheses mean that everybody shares the 3. So what's 3 times 4E?
12E.
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 Am I done? Can I add these two together? If I could add them together, I should have added them before I multiplied. But I can't. Can I add D's and E's?
No.
This is like Debbie and Elijah. There's my family.
70.
Or David and Elijah. Or David and Elizabeth. There are a lot of D's and E's in my family. Or Dave and Elijah or Elizabeth.
Wow.
There's only 2 people in my family who don't start with either D or E. We have Elijah and Elizabeth, and we have Dave, David, and Debbie. Anyway. Then we have Josh and Aaron. They're just their own people. Anyway. But we can't combine them because they're not the same, right? This is like donuts and eclairs. Like, they don't combine.
Declare.
Okay.
Both tasty.
They're
Just-
both tasty.
Just cut.
But we
cut the
can't,
donut
like,
in
they're
half.
not the same. You can't combine them.
Is it eclair a circle?
Eclairs are like,
Have you ever seen a eclair?
eclairs are like long things, and they're poofy, and they have a filling on the inside and frosting on top.
Oh,
just
that
like-
thing.
They're like a
donut
cream
in
puff that's long with frosting.
Cut the donut in half. Cut the eclair in half. Cut the eclair in half.
They're very
Take
different.
the curved part and stick it together.
Yeah, but see, but then that we can't. It wouldn't work. You can't combine donuts and eclairs.
They both have
Combine
frosting.
them.
We're not gonna combine donuts and eclairs.
Combine
Just
them.
create the declare.
I kind of want to go home and make some
Declare.
eclairs now, though, because they're really good and
I
they're like,
made them once.
they're really good
I
and
haven't made them.
they're weird, but they're easy. How do we feel?
I feel really good.
Okay, so what do we do the first half of the assignment? The first half of the assignment, we're pulling stuff out.
So,
First half of the assignment, we're pulling stuff out. Second half of the assignment, we're putting it back in. Okay? Because you guys know, I combine 2 assignments into one. So the other 6th graders get this in 2 different days. Austin's like so clueless because he got here late. Don't get here late, Austin.
can we do it?
No, we